This is 9.1, Properties of Radicals, Part 2. So, to rationalize a denominator is when a radical is in the denominator of a fraction. We're going to multiply that fraction by an appropriate form of 1 to eliminate the radical from the denominator. So we're getting rid of the radical in the denominator by multiplying by 1. So for root 5 over the square root of 3n, we're going to multiply top and bottom by the square root of 3n. This is a fancy form of 1 because when the numerator and denominators are the same, this equals 1. Now we have the square root of 5 times the square root of 3n over the square root of 3n times the square root of 3n, which is the square root of 3n squared. This square and the square root cancel out. So then we get all of these can go in the same radical, square root of 5 times 3 times n over 3n. 5 times 3 is 15, and we have an n over 3n. For the square root of 10 over the square root of 3, we're going to multiply each by square root of 3. So then we get the square root of 10 times 3 over the square root of 3 squared, which is square root of 30 over 3. Now we have 7 over the square root of 2x. Multiply each by square root of 2x. 7 times square root of 2x over square root of 2x squared is 7 times square root of 2x. This 7 cannot go inside the square root because it is not being a square rooted. It is not a square root of 7 right now. It's just a 7. And then the square and the square root cancel, so it's over 2x. 5 over the cubed root of 32. We can split this cubed root of 32 to simplify. That would be the cubed root of 8 times the cubed root of 4. We know the cubed root of 8 is 2, so now we just have this cubed root of 4. Now, I can't leave it like this. I can make it into another perfect cube by multiplying. So I'm going to multiply by the cubed root of 2 and the cubed root of 2. This numerator does not get simplified. So then we have 2 times the cubed root of 4 times 2. Since they're both cubed roots, they can go in the same radical. And now we know the cubed root of 4 times 2 is the cubed root of 8. We know the cubed root of 8 is 2. So then we have 5 times the cubed root of 2 over 2 times 2, which is 5 times the cubed root of 2 over 4.